Hello everybody, let's take a look at interval notation. Now interval notation is just a different way from representing sets of values from what we've used up until now. We are used to using inequality signs like greater than or less than or equal to. We are just now going to show a different way of saying the same thing. So let's start with linear inequalities. And at this point, I want to say that I am going to assume that you know how to solve a linear inequality. If you don't, please do the lesson on linear inequalities first before you take it from here. So let's start with the one on the left-hand side. In order to solve this inequality, we are going to say that minus 8x is less than minus 16. Because we have to divide by minus 8, we're going to reverse our sign and we have x is greater than 2. We mark the 2 on our number line, and because it's an exclusive inequality, remember the greater than and less than signs are exclusive inequalities, and the greater than or equal to and less than or equal to are inclusive inequalities. Because we're dealing with an exclusive inequality, we show it with an open circle and our arrow is pointing to positive infinity. With our compound inequality on the right-hand side, whatever we do to the middle, which is going to be to add 2, we have to do to both sides of our inequality. In other words, we're going to have minus 3 is less than x, and x is less than or equal to 12. Marking these two values on our number line, we show minus 3 and 12. Minus 3 is not included in our set because of the greater than sign for x, and 12 is included in our set because it's an inclusive inequality sign. X is every single value between those two values, including 12. So we know how to do this. We know how to represent our sets using inclusive and exclusive inequalities. Let's take this one step further into interval notation. Interval notation also has two kinds of notation. The round brackets we use for exclusive set values, and our square brackets we use for inclusive set values. The other thing we need to know about interval notation is that with our inequality notation, if we say that x is greater than 2, we don't need to say that it is greater than 2 up until infinity, because infinity is greater than 2, so it's assumed. With interval notation, we are specifying an interval. Each interval needs to have a start point and an end point, and even if that end point is infinity, we need to include it in our interval notation. Because positive and negative infinity are not specific values, they always get round brackets, our exclusive set signs. Inclusive values always shown with a square bracket. So let's look at the inequalities we just solved. With interval notation, we always approach from the side of negative infinity. Our starting point of our set is the first value that we reach. We would write this as x is an element. We use a round bracket because the value is not included, shown by the empty circle. The first value is 2. To get the last value of our set, we carry on. And then in this case, we can see that we're going to go all the way into infinity. So infinity gets included in our set, and we show that with a round bracket. For our next inequality, we are going to say that x is an element of round bracket because we are approaching from negative infinity. Our first value that we reach is not included, but we show that value as minus 3. We then continue all the way to our last value, which is at 12. 12 is included in our set, so we write 12 with a square bracket. We can see that our interval notation is the same as our inequality notation for both sets. It's just a different way of representing it. Now, when we talk about a union in interval notation, we are basically saying that a union is the same as saying or. So if we say x is less than 2 or x is greater than 9, that or in between is what we mean with union, and we show it with the sign U. So let's do that. For our inequality on the left-hand side, we'd say that x is less than -5. We can see the -5 is not included, or x is greater than or equal to 9. 9 is included. The equivalent interval notation would be that x is an element coming in from -infinity. We can see we start from -infinity, so we have a round bracket, -infinity. The last part of that set is at -5. -5 is not included. In order to show that the set is going to continue, we say union, and then we start at our next value, which is 9. Now 9 is included. Let's just do that properly. 9 is included, so we have a square bracket 9, and then our set continues all the way to positive infinity with a round bracket. Let's do another example. The one on the right-hand side would say that x is greater than 1, which is not included, less than or equal to 3, or x is greater than 8. Writing this in interval notation, we'd say that x is an element. Our first value is 1, which is not included. The end of that bit of the set is at 3, which is included. We then say union. The first value of the next part of the set is 8, which is not included, and that will go all the way to positive infinity. If all you do is remember that every single section of our interval notation has a start value and an end value with the associated bracket, you will never go wrong. You can have union a union between more than 2 bits of the set. Whatever values of x are included in your set, you need to indicate in your interval notation. So let's see if we can do an example where we go straight from our number line into interval notation. Remember, we always are starting from -infinity. So in this case, x is an element, and we can see because it's everything less than -8, we're starting at -infinity with a round bracket. The end of that bit of the set is at -8, which is not included. We then stop that bit of the set, but continue to the next bit, which is -3, not included, all the way to 1, which is included. So why is this important? Interval notation or inequality notation, it's a personal preference. Whichever one you want to use, as long as you're using it correctly, is perfectly acceptable. But often in tests and exams and exercises, you will be given restrictions in interval notation, and you need to know what it means and how to interpret it. The other place you'll use it is when you are specifically told to give your answer in interval notation. Then you need to be able to be comfortable with it. On your day-to-day basis, as long as you are indicating your sets properly, you can use whatever way you like.